Hello, I'm Roman, and welcome back to the series of the videos of neural networks from scratch in Go, where we using these neural networks from scratch in Python book, but rewriting everything with a Golang. Why with a Golang? Because why not? And in the previous, what was in the previous? In the previous, like yesterday, I started to dive into what is the lost function, and I took a look at actually I finished with what I finished with the activation softmax function, and then I started to dive what is the categorical cross entropy loss, and we checked the math behind this, and right now I'm going to implement this. So where is it? I think I stepped right here. So we're going to implement the function that takes array of the batches. Well, the idea for the calculation of the network, of the loss, is to take the desired output. Well, in our case, it's a category, so we will here there is a spiral data that returns 3 different data sets, and our neural network will try to predict it. Yes, it will try to predict it. So what we're going to do, we're going to calculate a loss function between we're going to implement how incorrect the prediction is in some number, and we're going to use the fancy name is categorial cross entropy loss, but in a nutshell we will just calculate some logarithmic function. And I'm trying to remember where I left. I think here the discussion about why we cannot take the logarithm from 0. And before we move on, there is one additional problem to solve: the softmax output, which is also an input to this loss function, consists of numbers in the range from 0 to 1, listed confidences. And in some cases, a model could be confident that it's not confident and return 0. It is possible that the model will have full confidence for one label, making all the remaining confidence 0. Similarly, it is also possible that the model will assign full confidence to a value that wasn't the target. So in any case, we'll try to calculate the loss for this confidence on the 0. And the logarithm from 0 returns infinity. And I think for us, it's not good. Before we expand this, we need to talk about the logarithm from 0. From the mathematical point of view, the logarithm from 0 is undefined. We already know the following dependent, that if y equals to logarithm from x, then e in power of y equals x. The question of what the result in y is in y equals to logarithm of 0 is the same question of how to solve this equation, like in what power number you need to raise it in order to get 0. In simplified terms, the constant t to any power is always a positive number, and there is no actually the solution that will make it a 0. This means that logarithm from 0 is undefined. We need to be aware of what the logarithm from 0 is, and undefined doesn't mean that we don't know anything about it. Since logarithm from 0 is undefined, what's the result for a value very close to 0? We can calculate the limit of a function. How to exactly calculate it's exceeded in the book, but the solution is the more x is going towards the 0, the more the value goes into the infinity. I think that's the right description. We read it as the limit of the natural logarithm of x with x approaching 0 from a positive equals negative infinity. What this means is that the limit is negative infinity for an infinite small x, where x never reaches 0. So the problem that, well, the x will never be 0. This situation is a bit different in the programming language. We don't have limits here, just a function which, given a parameter, returns some value. The negative logarithm of 0 in Python with numpy equals an infinity big number, infinitely, rather than undefined, and print a warning about the division by 0, which is a result of how this calculation is done. If negative log from 0 equals infinity, it is possible to calculate e to the power of e of negative here. In the programming, the fairer things that are undefined, the better. Later on, we'll see similar simplification, for example, when we calculate a derivative for an absolute value function, which doesn't exist for an input of 0. We'll have to make some decision to work around this. Back to the result. As much as it makes sense in the model would be fully run, this will be a problem for us to do further calculations. Later, with optimization, we'll also have a problem with calculating gradients, started with the mean value. I'll skip it for now. Yeah, so if we calculate the infinity, or if we calculate mean value between number and the infinity, it will be the infinity. We could add a very small value to the confidence to prevent it from being 0. For example, the e in power of -7. So it will result in some number. Adding a very small value, 1/10 of a million, to the confidence at its large h will insignificantly impact the result, but this method yields an additional 2 issues. First, in this case, well, the confidence is 1. Oh, yeah, so if it's 1, then we add the small number, we go beyond, and gives the very small negative value. When the model is fully correct in a prediction and puts all the confidence in its correct label, loss becomes a negative value instead of being 0. Yeah. The other problem here is shifting confidence towards 1, even if by a very small value. To prevent both issues, it's better to clip values from both sides by the same number in our case. That means that the lowest possible value will become this one, but the highest possible value, instead of being 1 plus, will become 1 minus, so slightly less than 0. Okay. This will prevent loss from being exactly 0, making it a very small value instead, but won't make it a negative value and won't bias overall loss towards 1. With our code and using numpy, we'll accomplish it by using clip method. This method can perform clipping on an array of values. We can apply it to the predictions directly and save it in a separate array we'll use shortly. So here we're going to actually implement the cross entropy loss. So I will make, so we have an activation, we have the data set, and we have the layer, and I will have the loss, right? And I will call it loss package loss. Will have the type calculate sample loss, calculate. So forward. Now we'll create the cross entropy loss right away. Categorial cross entropy loss. It will be a struct, I think, and then we will have the loss. Categorial cross entropy loss, and it will be calculate that takes output math dance, right? And it takes y as, I think that should be float 64. And we have the calculate and we have the forward. So that will be lot forward, which takes the prediction. I think it will be math dense, and I would call it target. That will be a subset of this. Right? Why are we doing this? Because calculate will take... Oh, it returns something. It returns number. So I think that will be missing a return. Okay. Yeah, so the loss function will take the softmax output and the class targets. Yes, so I will write it for now. We have the loss, right? Which is, oh, by the way, well, it won't store anything inside, but I still want to leave it as struct. Oh. We're going main loss like this. Even if it's empty, then we loss, and then we calculate in loss value, which will be taking the loss. We're going to take calculate. So for the output, we take in the softmax, and for the y, we take in this one, which is target classes, actually. Target classes, right? Okay. Wins 8. and then we print loss value, right? That should compile. Yes, so the current value is 0. So, and as the result, we should get the and as the result, we should get the lost value. Okay, so we I don't need this, and I don't need this. So we're going to implement this one. So the first one is we have the for. That's activations of max weight. Where is that? Combining. No, I have the calculate. And the forward returns sample losses, right? What it will return? Negative log likelihood, correct confidences. So that it's going to be an array. I think I will, not sure, maybe that should be float too, because I will take in some stuff from it, and it returns floats to 4. By the way, I'm not sure if I will be able to finish the implementation at least of the cross entropy loss, because soon I will have to go, but I will try to implement something meaningful. So what we have here, so we have sample losses, which will be the loss dot forward with the predictions. Okay, let's do it like this. So we have the output, we take in the data, I think the row matrix, we have the target, which will be the y, right? And that should be a, right? Then imagining that we have loss values, loss pulse, we going to use floats, and each does it have mean, average? Div dot max min mul subnorms. Log sum. Do I have somewhere mean value? Now I have to implement it. No. Instead of dealing with the slices. That's bad. Okay. And mean. Okay, let's take a look what it's. Turn the average of the array of the elements. Okay, so that should be float's sum, right? With sample losses, and it's divided by the length of sample losses, right? And then we'll return it. Okay. Come on, what do you do? Okay. That should be float 64. Missing return. Okay. We will return empty for now. Expected type, but found a new line like this. Make. Okay. Let's do like this. Nope. Make that. Okay. Oh, okay, that works. Number of samples in a batch. Number of samples, okay. Let's calculate samples. Count equals to len target, right? Define, because I need this. Then I need to clip predictions. So why predicted clipped? What it means? It means that I'm making the copy of the predictions. So prediction clipped. I'm creating the new float 64 array of the length of prediction. No floats copy. Oh, okay. Then what do I do? What do I do? Then I'm taking the prediction. Prediction copy. Nice. Prediction clipped. We have the copy, and then okay, we need a clip. So for I in range of prediction clipped, we prediction clipped be equal math. Do we have clip? Do we have a clip function? Oh, cursor most unnecessary. No, not this one. Not this one. Maybe I have it. Oh, okay, floats, it's 4 slices, right? Clip. Okay, we have the min value, which is... Can I? Okay, max value, which is e minus e this, and then math, right? We're taking the max value between... What is max? What is bigger? Prediction clipped, right? Or mean value, right? But then I need to take the mean value between... I'm going to write it here. I'm using the math mean between the prediction clipped and max value. Okay, so we have the clipped one, then probabilities for target values only if categorial. Oh, mask value is only for one hot. But I think I will implement the one way. Only one hot encoded values. Okay, we have the I'm just checking if I need to go earlier. Wait, so... So probably actually I need to leave this as math dance because I will have... This is not actually a no, it's a prediction, but not the one that I... So we will have it like this. And I'm making the copy, which will be the maths new then math. Can I copy just dense copy of prediction, right? And then for the range, Now, then I'm going to do prediction clipped apply, I think. Apply and so it takes a function. Applies the function fn to each of the elements in A, placing the result into the receiver. Oh, okay, so it's actually yeah, okay. I can just take the input the function fn takes, so this will be the prediction. And I'm curious how I would function param. So that will be func like this, right? So then we still taking this, and here we making the prediction at right like this. Oh, we have the V. We have B, and instead we actually return, right? Define prediction. And here I do this. So at this point, I think what we could have is the prediction dims and sample count samples, right? Can I get 0 from the tuple? At a single value count, but I want to take Okay. RC. Yes. So I have the target here, and here I will have 3 values for the target. Why I'm looking into this? I'm looking into this because probabilities for target values only if categorical labels, but I think only for one hot encoded. Oh, in my case, I need to implement this one. Correct confidence is I predict clip. So what I need to range samples. Okay, what I need. Negative log likelihood. So it will take. I'm trying to understand. I mean, why it's split. Okay. So it will return an array of confidences. Oh, okay, we assume that should be 0, so I need to take the clipped probabilities. Why it's probabilities for target values. Okay, so we have the values clipped. Okay. Gprint len maths formatted prediction clipped. Okay, but I need to return. Okay, so now I need to take probability from predictions clipped using target class. Right? I don't remember. Will it make it from 0? From 1? Class number equals 0. Okay. So basically, what we need to do, we need to make well, output, right? Oh, not output. The confidences we make in the plot 64 by len of target. Then we go in. Okay, then we go in for confidences. In the range. Well, probably correct will be target. And Okay. And then we take in the index as target y, and then we confidences, we take in the prediction clipped at I index. Can't use IDX. What is the value there? Int. Okay. That will be our confidences, and then we creating this thing, which again will be plot 64 by Lennon confidences, and for the range we calculating the negative. Yeah, I have a mix of styling, but okay. Math log logarithm from confidences I, and we multiplying it by -1, and then we return negative log likelihood. Boom. Oh, nice. Cool. Again, we get 33 values since the model is random, and its average loss is also not great for this data, as we're not yet trained our model to correct it. So, but what it means is actually don't need this. I mean, I would write it in the one function, but I can. I think the idea is that it calculates the loss and the forward prepares data for this. But I don't like that much copy, but I mean, we can actually write this in the confidence again. I think we can do it in one loop, but I mean, let's leave it as it is. I will stop for today as I really need to go. The one leftover for this chapter is we need to implement accuracy calculation, which sounds pretty simple, and then we'll go into the optimizations. So thank you for watching, and I see you tomorrow. Bye bye.